This is a run through of the solution for 2014 sample paper 2 question 8. It's the question about the solar panel. And you can see here we have our diagram as per the question and the information that we're given. AB is 30, AD is the same as CB, and that's 5 centimeters, CF is 22, and EF is 4. So part A of the question is giving us two triangles, and it's saying based on this information that we're given in the question, what values can we fill into these two diagrams? So let's have a look. So looking at the original diagram, first of all, we can see that A, which is down here, up as far as B, is 30. But we're also told that CB is 5 centimeters. So if the full distance is 30, well then the distance from C to A must be just 25. They also told us in the question that AD was 5. So this distance here from C to D must be 20 centimeters. So that allows me to write 20 in between C and D on this diagram. Again, going back to the original, I'm told that CF has a length of 22 centimeters, but I'm also told that EF here is 4. So subtracting that from the 22, that means the distance from C to E must be 18. And of course, the full distance CF, as I said, was 22, so that can go straight into this triangle. I don't know any information about AF or DE currently, so I can't fill anything in for those just yet. And this 60 was given to me in the diagram. Part B of the question asks me to use this triangle CAF to work out the angle CFA. So it's a good plan to first of all identify which angle that is. And it's this angle here, CFA. Since I know the side opposite the angle that I'm looking for, which is 25, and I know a matching pair of angle and opposite side, I'm going to be able to use a rule in trigonometry. So have a think for a second, what rule do you think that might be? So it's the sine rule. And the sine rule states that sine A over A equals to sine B over B. So now all I have to do is fill my information into this formula. So in this case, I've got the sine of the angle CFA over 25 equals the sine of 60 over 22. Now I want to get sine of the angle CFA by itself in the equation. And that gives me sine of the angle CFA equals to 25 sine 60 over 22. Okay, so now that I know the sine, I can use that to work out the angle. And if you prefer at this stage, you can evaluate this fraction here. So I'll do that now first. So this fraction simplifies down to 0.9841. I've kept a good few decimal places here so that I get accuracy in my final answer. And now to find the angle, I'm going to use sine inverse. So it's sine inverse 0.9841. And the angle I get as a result is 79.8. Part C of the question asks me to find the angle ACF. So that's this angle up here at the top. And since I know the other two angles are 60, and I just found 79.8, it's easy to get the third angle by just taking those two away from 180. And I get 40.2 degrees. Now just notice, this angle that I have at C is the same angle as this angle here in the right-hand triangle, and that's going to be useful in the next part of the question. So I'm just filling that in now to the diagram. Part D of the question tells me to use that triangle CDE to find DE. So this is the side that I want to find the length of. Now again, I'm dealing with triangles, so I'm going to have to use some rule in trigonometry to work that out. So stop and have a think for a second. What rule do you think we're going to have to use in this case? So earlier in the question we used the sine rule, and that was possible because we had a matching angle and a side that was opposite it. But if I have a look at this triangle here, I don't know a matching side and angle. Okay, so if I don't have matching sides and angles, then I can't use the sine rule. So I'm going to use the cosine rule instead. You can see here that I've got two sides and the included angle. So that always lets me know that I can use cosine rule. The first thing that I'll do is make a note of the rule. The cosine rule is a squared equals b squared plus c squared minus 2bc cos a. It wouldn't be a bad idea to go up here first of all and label this triangle with the a's, b's and c's. And generally, whichever piece of information it is that you're trying to find, if you call that A, that'll make the formula kind of easiest to deal with. So I want to find the side DE. So I'm going to start by calling it A. Now B and C as sides are fairly interchangeable. So the 20 and 18, either of those can be the B or the C. And the side A is always opposite the angle A. So this angle here, 40.2, will be called A for the purposes of the formula. And now I'll take those values and fill them in. And I can type this straight into my calculator to get A squared. And again, I'm keeping a good few decimal places there because I'm not quite at my final answer yet. And then finally, to find A, I just have to square root that value. When I square root, I get 13.2 centimetres. I've still got it called A here just to finish it off nice and tidily. I'll call it by the name they gave it in the question, which was DE. So DE equals to 13.2 centimetres. Notice there how I rounded to one decimal place because they asked me to do so in the question.